Hello and welcome again to another edition of the Osteopathic Lyceum podcast. I'm going to try to string together some ideas, partially just to put them out there with respect to artificial intelligence and osteopathic manual therapy. So first, the thing that I want to do is try to speak to what I understand with respect to what is being termed artificial intelligence. As far as I'm aware, what most people are talking about when they're speaking about artificial intelligence is really a large language model, which is underpinned by what I understand to be a statistical probability model. And what it's trying to predict is the next most likely letter, the next most likely word, the next most likely sentence, things of that nature. And it seems to do a generally good job with respect to what most people would experience as its output. Something that can be very challenging with respect to the fact that it is language intermediated, or really more so writing intermediated, such that it needs a written prompt in some way, shape, or form. So you can go voice to text, I think, with some or many of them, but it requires words to generate parameters for it to make its statistical prediction and then provide you with that output. So you end up with a roadblock initially with respect to who can use large language models well. So you need people with appropriate understanding of what the large language model is built to do, how it is built to respond to prompts, and the ability to effectively write the prompt or word the prompt in an order that will give you what you're looking for. So you still have to have a target. You still have to have some knowledge of what the heck you want it to do. Then you have to have enough command of a language in order to get it to do that thing in that language. So there's an initial roadblock. People who have higher levels of mastery of a language are likely to be able to get more out of any form of large language model. So you're likely going to require a fundamental skill set before you can use it well. Then we have the language challenge. We also have the data challenge. There's a phenomenon that is called GIGO, or the acronym is GIGO, garbage in, garbage out. So depending on the data available that the large language model has as input or as data to be trained on, it is only able to put things out related to the data it's been trained on. So if it's been trained on garbage, it can give you garbage. Obviously, that's not the case in most of the large language models. They've got pretty broad data sets. There are some concerns with respect to how that data is found and utilized, that with respect to things like intellectual property, copyright, stuff like that. So there's some challenges brewing there. The deal with the large language models, depending on the particular topic, if things are not written out, knowledge contained within that topic is not written out, then it can't be represented in the data set. If it is written out, but it's not inside of the training data set of a particular large language model, then it can't be included in the answer. So you have some pretty harsh boundaries depending on the specific thing that you need it for. With respect to osteopathic manual therapy, I mean, it depends on the databases that the large language models have access to. Also, sometimes it may depend on how strongly the information that may be contained in the data set about osteopathic manual therapy is weighted and utilized. So it may not be the best. I haven't tried it. Well, I really haven't tried to mess with any large language models because I have preferences, but I am saying that because I don't know if I can comment on how effective they are. I can just predict that I'm not sure that they're all that effective when speaking about specifically osteopathic manual therapy. Another challenge with osteopathic manual therapy is saying that I know from people before me, and it's pretty flippant and colloquial. It's if you have 5 osteopathic practitioners in a room, you're going to have 10 opinions on the same topic, right? So there's a wide variety of opinions contained within osteopathy, a wide variety of approaches and ideas, and low levels of agreement. So you've got that as an issue, right? So the variety of opinions on a given topic that may be represented in a database with respect to osteopathy can be a problem. So it's harder to figure out what the heck the thing should say or what the thing should type as output. It's harder to figure out if it has appropriate data for your question. So there's challenges with the data that is available within the given large language model. And maybe one question you have about osteopathic manual therapy may be better done by one large language model, and then that model will do poorly on another question, and then you need another one. So there's challenges with the data. There's challenges with the prompt engineering. There's challenges with the data. In order to have the baseline skill set to appropriately use language to get a large language model to do what you're hoping for it to do, or to explore the topic that you're hoping for it to explore, you likely have to have gone through skill building. I don't want to use the term education specifically because it doesn't necessarily need to relate to the term education. Some may argue that it always would, depending on how you use the term, so you need to agree upon a definition of the term education. I'm not here to do that right now, but a skill building process to develop the skill of masterfully using a language, and also then being able to apply that skill to how a specific large language model is functioning. So you have to have gone through some level of skill building as an individual to get to the point where you can actually use the large language model well. So obviously I've already touched on that, but what I'm really trying to point to is the skill building process. If you don't build the fundamental skill to be masterful of the language, large language model is not likely to perform at its top level for you. Also given that it has the appropriate data in its training set to do what you need it to do, or want it to do rather. So to focus on the skill building, one of the things I've heard, and I haven't necessarily vetted this claim, that there is some concern and a phenomenon whereby people from prestigious educational institutions, I believe this is from America, are coming out of their prestigious education institution with very high marks, which used to be a proxy for having a certain level of skill. One can argue about the validity of any form of education and testing regime, but generally speaking, the more prestigious the university has been, or an educational institution has been in the past, if people have high grades there, they usually have higher levels of skill. They also usually have better interpersonal networks to put them in positions where they can wield those skills a little bit better. Now, that's obviously not always true, but at least sometimes it seems to be the case. With respect to the more prestigious the university, the better your interpersonal network for people to help you get into positions to use your skills that you developed. So the phenomenon that seems to be showing up is people are coming out of prestigious educational institutions with very good marks and are apparently being fired from entry-level positions. Now, being fired from an entry-level position doesn't necessarily mean something about skill, but I think it's fair to predict that it means something about skill. So the high marks apparently have been achieved with the help of a large language model, such that when the person comes out into their job to try to apply the skills that they should have learned to go along with their good grades, they don't show that they possess the ability to use those skills. So either they didn't develop them or they can't use them. And it seems to at least be in relation to using the artificial intelligence or large language model to obtain those grades. So essentially what seems to have happened, they've gotten to a level where they've been able to prompt engineer appropriately, get things through their educational institution. Varying educational institutions have varying policies on the use of large language models for academic work. So some may be more lenient, some may be more strict and harsh. The thing that I think is being missed, or that my preferences suggest is being missed, is the development of the skill. So I can use the story, and maybe it's an accurate story, maybe it's less accurate than I'm aware of, but the story of people coming out of prestigious educational institutions with really good grades and being fired from entry-level jobs to suggest that those people, in the manner in which they use large language models to obtain those grades, to whatever degree they did or did not, and obviously I'm leaning more towards they did, they seem to have robbed themselves of the skill development that is common with university completion, or the process from getting from entry to university to graduation from university at whatever level. There should be a skill improvement of some form, often in the form of cognition and a language use on a specific topic. It doesn't necessarily generalize broadly. So the generalizable thinking skill doesn't seem to be the thing we want it to be. So learning something that's complicated doesn't necessarily make you a better thinker in other areas. It makes you better at that specific area. So let's just say you take physics and you get really good at physics. It doesn't necessarily mean you're good at poetry. The generalizability of the thinking and the cognition seems to be lower than would be hoped. It seems that you get good at the things you do over and over again. So if you do physics over and over again, you get good at physics and expressing yourself within the language and culture of physics. If you do poetry over and over again, you should get better at expressing yourself in the language and culture of poetry, whatever that may mean. If you do osteopathic manual therapy over and over again, you should get better at doing osteopathic manual therapy, right? Within that realm, within the physical expression of that. So here's where osteopathy diverges a little bit from some fields. It is physical, no matter what you want to think. No matter what your preference is, osteopathy is physical, and it's physical between two people. Whether it's a patient-active approach or a patient-passive approach, one person is attempting to utilize their knowledge and skills to help another person. Now, that person can be more active, more passive. Either way, it's still a physical and cognitive interface. So my concern with the use of artificial intelligence in any educational institution is that the learners are, by proxy, showing that the hierarchy is the letter or number grade. Now, they are supported in thinking that by the opportunities that seem to be provided when your letter or number grade are higher on the scale through the university system, through some form of promotion, depending on exactly where you are. When you do more of what somebody wants and prefers, you seem to get more reward. Not exclusively, but often. So university students and primary school students, secondary school students have at the top of their hierarchy, in many cases, the letter or number grade. So they figure out how to behave in order to get the output of the letter or number grade they're looking for. The challenge with that, and it's a classic challenge, is that the hierarchy, at the top of the hierarchy, should be improvement and progress in skill, cognition, through experience, or skill and cognition through experience. So you should get better at stuff. You don't have to have good grades to start. You should have better grades to end. So whatever grade you start with, if you have better grades later on, that is the point. However, because you are rewarded with having that higher grade, whether it's letter or number, the game becomes optimizing for that. And understandably so. So it's not to say that shouldn't be the case, because especially classically or in previous points of time to now, that higher grade or in letter or number often did relate to more skill. My understanding with respect to, what's the proper term? Legal interactions. So physicians who get sued, right? So physicians getting sued for malpractice of some form, those who tend to score higher on standardized tests and board exams tend to have less legal action taken against them. Now, I don't know if that is a repeated finding or if it was a one-time finding, but I do know that I've at least encountered that information. Those people that did better on board exams seem to have lower amounts of legal interaction due to malpractice, right? The suggestion by proxy is that their skills are better, and because their skills are better, they perform better, right? So there is a history of higher number and letter grades relating to higher skill and knowledge, but there seems to be something happening here whereby, because the game is higher letter or number grade, people are optimizing that in a way that is robbing them of the stepwise skill improvement, right? So the point of the educational process or the skill building process is to go from wherever your performance is now to better performance over time through learning, primarily in the form of error commission, identification, and correction. But because you can shortcut that system or shortcut that process and game it with large language models, we're likely seeing people who are robbing themselves of the skills, knowledge, and experience gained through a skill building process or an educational process. So we're probably going to run into this more for at least a little while before there may be a correction, or maybe there won't be a correction. But my simple concern is that those that are, say, optimist with respect to many fields, they like technology and they want to bring it in. And I get it. It's your preference. It's the thing you like. You want to bring it in everywhere because it's awesome. It's a panacea. It's going to do everything great. Well, technology doesn't always evenly impact things in the way predicted. So an example I can give of this is something I've talked about before at McMaster University, the anatomy department, primarily through Dr. Bruce Wainman, who was the head. I believe Dr. Wainman has retired officially, so I don't know if he's a professor emeritus or if he's fully retired, but Dr. Wainman and Dr. Danielle Brewer-Deluce, and I really never know if the last two letters are more of an S sound or more of a ch sound, so I don't know if it's Deluce or Deluce. I don't know, and I say it a lot, so I hope I'm not messing up her name too much. But Dr. Wainman and Dr. Brewer-Deluce have done work comparing virtual reality goggles and 3D anatomy, whether it's simulated 3D on something like a tablet or simulated 3D through VR goggles versus 3D plastic models and classic paper anatomical drawings with respect to performance outcomes on anatomical tests, primarily bell ringers, so primarily structure, location, and name recall. The VR does not outperform paper in some circumstances. So the VR is more expensive, needs to be updated, you need to update the hardware, the software. It doesn't outperform a 3D plastic model. The 3D plastic model outperforms paper and the VR, generally speaking. They've also investigated scale of 3D plastic models. So for some anatomical structures, it seems like the common scale is most appropriate. So something like the pelvis, you don't need to make it bigger or smaller. Its normal size is big enough for people to learn well from a 3D plastic model. Whereas with respect to, say, some vertebrae, there is a scaling up that seems to actually positively impact anatomical name and location recall on testing. So they've been playing around with this, trying to figure out what actually works to improve performance across groups. Whereas Dr. Wainman initially, because he is a tech optimist, he likes the idea of the virtual reality goggles and 3D anatomy in that way. But he wanted to test it, and it doesn't outperform standard methods that already exist. So spending money on it may not be that useful. So that's kind of an analog. It's not absolutely the same thing, but it's just to show through story how the adoption of technology doesn't necessarily do what you would want it to do. It would be great if something new worked better than something that already pre-existed, but it's not always the case. So with respect to a physical modality whereby you have to learn how to move your body in relation to another body and respond to how that other body responds to what you're doing, there's refinement of motor skill across time. There's refinement of attention and observation skill across time. And that has to be combined with some level of cognition. I would argue that the level of anatomy that osteopathic practitioners need to learn is nowhere near what some people have classically claimed. However, because it's already part of the culture, you'd have a hard time convincing many people that a lower level of specificity with anatomy is required. So I'm not going to say with a heavy hand that it has to change. I'm going to say that I don't know that it has to be at the level that people think it has to be at, especially right now. So you have to have some cognitive development. You have to have some specific knowledge development with respect to anatomy, some physiology, some gross pathology. I don't think pathophysiology is that important for osteopathic practitioners because they can't properly observe it or measure it in most cases. So they can't observe the change in physiology the same way they can observe the change in gross pathology, aka gross movement of structures, especially externally observable structures, so like the neck, the shoulder, the knee. They can identify when something's wrong, but they may not necessarily know exactly what's wrong to the point whereby they could interface with it in a safe way under some circumstances. So if you think it's broke or torn, you don't do anything to it because you don't know. You can You can identify abnormal movement that makes you think it could be broken or torn, especially compared with recent trauma or recent impact. And then you can say, hey, somebody else who can identify the internal stuff better should do so. So, little tangent, so I'm sorry. The basic idea is that you need some cognitive development to be able to integrate the appropriate knowledge to be safe as a baseline concept, as well as the physical motor skill to move in relation to another person's body, so to move their body in relation to yours, and to respond to how they respond and change how you're moving. So you need those repeated motor skills and observation skills. Then the cognition to be safe. Also the background knowledge to know a way to start to try to move a person's body in relation to your body, and then respond and change. So what way would it be reasonable to start based on what I found? If that doesn't work, what is reasonable to try next? If that doesn't work, what is reasonable to try next? So there is some problem-solving skill that needs to be built. If you utilize something to offload the process of starting with uncertainty or starting with lack of knowledge and working towards having higher confidence in the knowledge you do have or the thought you are having in the approach, if you shortcut that in any way, you're robbing yourself of the skills, the knowledge, and the experience that are going to make you better at your actual embodied physical job or your embodied physical practice. So I don't think osteopathy should be bullish in any way on artificial intelligence. Maybe outside of something like question writing, right? I have seen some research where artificial intelligence or really large language models seem to show reliable abilities to generate good test questions for standardized tests in healthcare. So I think it was USMLE question development that I saw the research on. I do not remember exactly, but I have seen something to suggest that a pool of experts was able to, a pool of expert item writers for a standardized medical testing procedure for like an actual test, like a multiple choice test, whereby the large language model was able to generally reliably write good test items. So that may help workload. The thing to keep in mind is that there has been prior skill development in these people who would be considered experts where they're able to identify on some level that those test items are acceptable, so they know enough to know if it's a decent item and then also test whether it's a decent item. And then they're also able to compare and contrast to what they have done to what they could do in the future. It can help them get better at their own test writing process or item question writing process. But it seems to be better in a supportive role than a role of taking over, because if everybody shortcuts their ability to generate good test questions, good test items, then you'll never know, or that's not true. You'll have a much harder time determining whether or not the large language model is still doing a good job of writing these test items, these test questions. So I also have seen some information that suggests, at least from medical doctors, that utilizing artificial intelligence, really large language model diagnostic assistance seems to be somewhat positive. It's not fantastic, but it seems to be somewhat positive. And it was Dr. Matthew Sibbald who worked with a group of people to try to determine whether or not it was better to use the large language model help early in a diagnostic process or later in a diagnostic process. And I don't remember the outcome, but I do remember that Dr. Sibbald and some co-writers worked on that and experimented with that. So I just don't remember the outcome. But these things are happening. It pays to be aware of them on some level. Because I'm aware of them on some level, I think that it's probably not that useful for somebody who's trying to become an osteopathic practitioner to lean into the utilization of large language models, especially in your education process. I think you're robbing yourself of the problem-solving skills because, again, if you offload those problem-solving skills to a large language model, you don't develop them. And those are the skills that are going to help you clinically interface with the person that's presenting themselves to utilize your skills, knowledge, and experience. So if you don't develop your skills, knowledge, and experience appropriately and you just got good grades, there's another problem. So you're still going to have to develop that knowledge, skill, and experience, right? Or knowledge and skills through experience. You're just going to do it at the time that's less advantageous to yourself and the people who are presenting for your skills, knowledge, and experience. Right? So overall, I think there are some possible benefits and some places where large language models can be beneficial. I really don't think it's there in the educational process, especially for osteopathic manual practitioners, because you're going to be shortcutting the wrong stuff. Sure, you'll get better grades, but you're shortcutting the stuff that could have got you the grades that you would have earned, taught you what you need to get better at, and then you could have applied that effort prior to getting into your, the bulk of your career with respect to interacting with the general public who's asking for your knowledge, skills, and experience. So again, I think it has some benefits. I just don't think it's there in the educational process for osteopathic manual practitioners. And I really just want to try to bring together a bunch of those pieces of information so that at this point in time, the things that I think and the way that I'm putting it together is out there for people to see. So thank you for sticking around this long. Hopefully you learned something, and we'll talk again soon.